Okay, so this is a lecture on the Bellman-Ford algorithm. It's a single source shortest path dynamic programming. It also uses negative edges. So there's a -2, -1 there, so negative edges. Now, how do we figure out the shortest path using Bellman-Ford? We're going to start, we have 1, 2, 3, 4, 5, 6 edges. So since there are 6 vertices, we're going to go 6 minus 1, so we're going to go through these 5 times. If you look back here, these are the edges. A to B, A to C, which is 4, A to D, which is 5, B to E, -1, C to E, C to E is 3, C to B is -2, then I got D there, D to F, D to C, and E to F. That's it. Those are the edges. So 1, 2, 3, 4, 5, 6, 7, 8. So there are 9 edges. So I counted for all 9 edges. I'm going to start with 0 here from the source. And I'm going to put infinity to the rest of the other vertices. So these are all infinity. How do we calculate this? First time through, we have to go through each one of these. A to B, 0 plus 6. Well, 0 plus 6 is 6. That's less than infinity. So I'm going to substitute that. So according to that formula there. Now, A to C is 0 plus 4. That's better than infinity, so I put 4. A to D, 0 plus 5. It's 5 is better than infinity. B to E. B to E, 6 plus 1 plus -1, that's a 5. So I put that into 5. C to E. C to E. 4 plus 3, 7. Well, 5 is better. Don't bother. C to B, I have 4, -2, 6, so that's a 2, which is better than 2 is better than 4 plus -2 is 2 is better than 6. D to E, so I got D to F. Okay, D to F. 5 plus -1, that's a 4, so I'm going to take 4, it's less. Now D to C, 5 plus -2, that's a 3, which is better than 4, so I change that to 3. Now E to F, E, which is 5 plus 3, so 4 is better, so leave it as it is. So this is my first pass. Let's go through it again. A to B, 0 plus 6, 2, I can't change it. A to C, 0 plus 4, that's a 3, can't change it. A to D, 0 plus 5 is still 5, don't change it. B to E, 2 plus -1, it's 1, so it's better than 5, so I put 1 there. C to E, 3 plus 3, that's a 6, well, 1 is better. C to B, 3 plus -2, which is a 1, so it's better than 2, so I'm going to change it to 1. D to F, 5 plus -1, 4, don't change it. D to C, 5 plus -2, 3 is the same. E to F, 1 plus 3, 4, that's 4, it's the same. That's my second pass. We got 5 to do. Third time. A to B, 0 plus 6, can't change it. A to C, 0 plus 4, can't change it. A to D, 0 plus 5 is still 5, can't change it. B to E, 1 plus -1, which is 0, so I can change this to 0. C to E, C to E. 3 plus 3 is 0, 3 plus 3 is 6, so that's a 0, can't change it. C to B, 3 plus negative 2, that's a 1, can't change it. D to F, D to F, 5 plus, so that's 5 plus negative 1, that's a 4, can't change it. D to C, 5 plus negative 2, 3, can't change it. E to F, 0 plus 3, which is 3, so it's better than 4. Okay, that's my third pass. So let's go through it one more time. Okay, A to B, so 0 plus 6, that's a 1, can't change it. A to C, 0 plus 4, can't change it. A to D, that's a 5. B to E, which is 1, negative 1, so can't change it. C to E, C to E, 3 plus 3, can't change it. C to B, 3 plus negative 2, that's a 1, same thing, can't change it. D to F, D to F, 5 plus negative 1, that's a 4, so I got a 3, can't change it. D to C, D to C, 5 plus negative 2, that's a 3, can't change it. E to F, E to F, I got 0 plus 3, that's a 3. So this is my fourth pass. I'm going to do it one more time, okay, just to get you the practice here. 0 plus 6, that's a 1, can't change it. A to C, 0 plus 4, can't change it. A to D, 0 plus 5, can't change it. B to E, 1 negative, so 1 plus negative 1, that's a 0, can't change it. Okay, how about C to E? C to E, 3 plus, so can't change it. How about C to B? C to B would be 3, can't change it. D to F, 5, so can't change it. D to C, 5 plus negative 2, that's a 3, can't change it. E to F, 0 plus 3, that's a 3. That's it, we're done. So all I got to do now is do my edges, okay? So if we look at the edges, what is A? Okay, that's a 0. How about B? This is my table. B is what? 1. How about C? C is actually 3. D is actually 5. E is 0. And F is 3. Did I count for all of them? I got A, I got B, C, D, E, and F. So those are the shortest path. So if you look back here, that's why it's dynamic programming, and I was able to accept negative edges. Okay, and so this is what's known as the Bellman Ford algorithm, single source shortest path algorithm. Thank you.